share Desmos, and we're going to look at this together. So x plus y less than or equal to 8, something like that. And then y less than equal to minus 1/2 x plus 6. So currently you can click there and find that vertex point. The thing that might not be really useful is that the decimals don't tell you the fractional answers, but that's okay. And then x is greater than, or I'm sorry, y is greater than, oops. 6. Oh, maybe that's why. Okay. They do meet in a nice place. If I type the correct equation, y greater than or equal to 1/3 x. Okay. Now, what could be confusing here, because I'm already sort of confused, is which region are they all overlapping in?
Yeah.
And maybe you know that how to do this, maybe you don't. But here's what I'm going to do. I'm going to change the direction of all of these inequalities.
Mm-hmm.
So I'm going to make this greater than or equal to. I'm going to change the second one to a greater than or equal to. And then I'm going to change this one to a less than or equal to. Okay. And what you're looking for now is, and I'm going to, so I actually have to add in the last two. So they're x greater than or equal to 0. We don't want that. And then y greater than or equal to 0. We don't want that. But we want to flip those. So when you change the direction of them, you have to do it for all of them.
Yeah, it's like the white part.
It's the white region, and that makes it very easy. And this is the way it should be taught to be best explanation. It gives you the region that you care about, and then you can also get all these vertices that you care about.
Oh, okay. Yeah, I didn't know how to do that part of it.
Now, what I'm highlighting is all the vertices.
Yeah.
And I think I got them all. I just think there's one more there. And then I'm going to snip this.
Okay.
Now, the graph he gave was not good enough for this. I'm going to paste this into our notes. But you can see now. You can see the vertices. So the vertices are, and I'm gonna share the workspace again, but it's 0, 6. Actually, let's 0, 0 right there at the lower left. Let me lower left, and then 0, 6. And then there's this one where the two lines intersect at 4, 4. And then there's another one over here at 6, 2. And those are the only vertices. The other ones that I've highlighted here, they're just intersections if you need to show them. Okay. So I'm going to go back to sharing the workspace here. You should see the ordered pairs here, and then the maximum. I've always made a table. It doesn't work great for this, but you're using this equation right here. And there's actually room. I guess we'll do it. I guess we can do it right here. So it's like the x comma y, and then the value of p. So at 0, 0, it's 3 times 0 plus 2 times 0, which is 0. 0, 6, 3 times 0 plus 2 times 6, which is 12. 4, 4, 3 times 4 plus 2 times 4, 12 plus 8 is 20. And then 6, 2, we have 3 times 6 plus 2 times 2. That's 18 plus 4, that's 22. So it's a maximum of 22 at 6, 2.
Okay.
All right, so I'm going to go back and look at your exam again. Let's see. Did you? Let me see here. I just want to check the solution to this one, meaning I'm just going to try and get the x, y, and z values and see. He says you lost track of a sign. I
Yeah,
don't know if that I don't know if that means that you have.
I got it
Um,
like totally wrong, so I'm
yeah,
not
you
sure.
did. I am super surprised you only lost a point on there because the answer is pretty
Yeah.
nice. It's 2 minus 3 1, but for 1 point I wouldn't tell you to do a correction unless you could get that full point back. Even then, we
Yeah.
probably should do it at the end.
But yeah, he just has it so if we correct everything, we get like half of the points back.
Okay. So the next one that I suggest we do is 13.
Okay.
So I'm going to do the same thing as we did for this previous problem 8. Is I'm going to snip in the um, the problem, and then we'll definitely go to Desmos to find it. I'm actually pleased that your instructor is allowing you to use technology, because to do this by hand is sort of a pain.
Yeah.
So there's the system, and we're going to do a new share. Because this is not an inequality, the ones that we just graphed were inequalities. It makes sense to use that switching of the signs for those, but not for this one. Like you would just leave this as is. You would just graph it exactly the way it shows here. Y equals 0.5 absolute value. I wonder if the vertical lines work. X minus 1 minus 4. Okay, so there's some intercepts there and there, might be useful. Y equals minus 2 vertical line, X minus 2 plus 5. Okay. So they want you to find the intersection of them. And your picture looked really close to this. But when you graph this, like if it were me and I was a student and I was allowed to use this technology, like I would want to snip in this graph into, actually, let me get the intersection points, and I would just feel like I was done after snipping that in,
Yeah.
because there's nothing more to do. They don't even work out nicely where you can just be like, yeah, I did this, but then I verified it without that. Let me new share, just get back to our screen. So what I did is I copied in the graph into our workspace here, and you can just see, I mean, those are the points. And that's the solution. I mean, there's nothing more to do on this.
Yeah.
So, I mean, you lost 2 points on that one, I think. Ooh, battery's running low. Okay. So that you lost a couple points there, but not enough that, I mean, it doesn't even, I mean, it looks like you probably got a B, high B on this.
Yeah, I got like an 87, so
Yeah.
uh,
So you can get, half the, you can get a little bit back on this. So 9 would be the next one to go through if you'd like.
okay.
Otherwise, 11, I don't know what you lost points for on.
Yeah, I'm not sure what he wanted for that one.
You calculate to put the matrix in reduced row echelon form. You have that.
Yeah.
Unless your answer is wrong, meaning like you wrote it down wrong, not that it actually is wrong.
Yeah, I can check it, but I mean, I had like 5 minutes left to do this part of the test, so
Okay.
it's kind of going crazy.
12, you lost a point on the expense equation.
Yeah, I just have no idea how to do that.
Okay, so 12 requires you to use your calculator to create a regression model. Did you do that for the, I mean, you either did it for the income equation or I don't know how you got that income
Yeah,
equation.
I didn't know how to use my calculator for that, so I just guessed.
Okay. Well, help me out here, I mean, there's 1 point on 12 to get back, and 11, I have no idea. So we can either, and then eight you lost, or I'm sorry, 9 you lost 1 point, but it's completely wrong, so we have to redo it. Where should we go from here?
Can we work through 9?
Yes.
Okay.
Okay, so let's start with 9, and let me snip that into our workspace. It's almost always the case that you use substitution to solve these. I'm sorry, elimination. I can't believe I said the wrong word. Because the substitution very confusing if you get more than two equations. Can you see the? Are you seeing the snipped solve the system?
Yeah, I can see that.
Okay. All right. So I put a 1 next to the x here because you can eliminate x in either of these pretty easily. And that's usually a common thing to do. So like if you multiply the first equation by -2, you can add it to the second equation and get rid of x. Now
Mhm.
looking at your work, it looks like you tried to eliminate x from the second and the third equation.
Yeah.
So the better option would have been to use the first equation to eliminate x in the second two, or even to use y to eliminate y in the first two. But we'll probably just have to redo this. So we got -2x minus 2y minus 2z equals 0. Then we have this equation here, 2x minus 3y plus z equals 14. If we add them together, you get minus 5y minus 1z equals 14. Is that okay? Any issues with that?
Yeah.
Okay, now if you multiply this first equation now by 3, you're going to get 3x to go with that 3x that I'm circling, and you can eliminate the x. So we're going to have 3x plus 3y plus 3z equals 0. And then I'm going to write that third equation, minus 3x plus 2y plus 5z equals -7. And you get 5y plus 8z equals -7. So the key here is you got two equations, two unknowns. It's the same unknowns here. So I'm just going to take this one and move it underneath the other one. So you got minus 5y minus 1z equals 14. Add it together. The y's go away. That's really nice. And you get 7z equals 7. Divide both sides by 7. So z equals 1.
Okay.
Now you have two equations you can go back to. You can either go back to this one with the arrow or this one with the arrow and find y. It doesn't matter, but I'm going to choose this one. I'm going to bring it down here. 5y plus 8z equals negative 7. I'm going to put that 1 in for z. So you have 5y plus 8 equals negative 7. Subtract 8 from both sides, and you get 5y equals negative 15. Divide both sides by 5. Y equals negative 3. So we have two pieces of the puzzle. We needed two of the three variables. So now we can go back and we can use any of the three equations. Well, the first one is pretty inviting because it's just x plus y plus z equals 0. X plus y plus z equals 0. We know that y is negative 3. We know that z is 1 because we found those. So we have x plus negative 2 equals 0. Add 2 to both sides, so x equals positive 2. The solution is then 2 comma negative 3 comma 1.
Okay.
Your instructor, my opinion is he was unwilling to try to follow your work.
Yeah.
And I'm really surprised you got 8 out of 9. But that's the way it goes. So like I said, number 11, no idea why you lost a point there, unless your reduced row echelon form is wrong, because it is consistent with how you're supposed to present the answer.
Yeah, I can email him about that. It might be a mistake.
There is okay. So there's a small problem in your work. The third row here. I'm gonna snip this in so we can both be looking at the same thing here. If I look at the original equation, the third equation from the exam says 3x minus 2z equals minus 13.
Oh, I
Y
put
is 0y. So this
yeah.
should be a 0 and that should be a minus 2.
Okay.
Maybe it just happened to work out. I mean, that's pretty
Yeah.
shocking.
Oh, I might have just I don't know. I might have put it in right to the matrix but wrote it down wrong.
Yeah. So not sure how you get points back on that, but
Yeah.
maybe give that a try
Okay.
to see if there's something there. 12. Okay. So you have data that you have to put into your calculator. So do you have your TI 83 handy? Or 84, whatever you got?
Yes.
Okay. So you have to get to list. And I think it's Y1, you're going to put in 1, 2, 3, 4. And Y2, you're going to put in 1500, 3500, 5500, 7500. When you get that done, we can then talk about what to do next. I don't have really an ability to share a calculator screen,
Yeah.
so I'm going to I'm gonna do this in a different way, and we'll hopefully get the same results.
Okay.
All right, so for the first one, your equation should be y equals minus 500 plus 2000x.
Okay.
For the second one, you have to keep it really simple, you have to put the values and the expenses into y2. Like you replace all the values that are there.
Okay.
Now, I see that I think you got these values. Let me check your exam. Oh, I see. You have your intercept for the second one is not correct. Let me
Yeah.
snip that in so I can show you. So this value should be that one, 24,000.
Okay. Okay, I think that's all I need to see for the test. And
Okay.
then I sent you another problem that was due a few weeks ago, but I haven't done it yet.
Okay. So remind me on these. Does the answer matter, or is the process, or is it both? What are they looking for here?
Um, we have to write out like in like a paragraph style, even if we get the problem wrong and just write everything out, we can still get like a 90.
Okay. So it looks like it goes up third locker, fourth locker, fifth locker, and then that went on forever. So, um, okay. So let me do this. I've got I want to do this in Excel, not because it needs Excel, but I think the visualization will be better. Um, and I think this will be useful, but I'm not sure. I'm not sharing my screen yet. I'm just getting a little setup here, and then
Got it.
we can do this. Do you have the question in front of you, or do I need to paste that into?
I have it in front of me.
Okay. All right. So you should be seeing my screen,
Yeah.
and I made I just what I did is I created a locker sequence here, and then are they all the lockers start out locked? Okay. So we're going to use a 1. Is 1 okay to mean locked, or do you want to use 0 for locked?
Um, yeah, one's fine.
Okay, so we've got to make a note of that 1 means locked. Okay, great. Now, what does it say happened on the second day, or on
The
second day?
second day, all the odd numbered lockers were locked and all the
Okay,
even ones were unlocked.
all right. So what what does it mean if it's odd? Like, how can you, do you have any, like, how do you determine if a number is odd or not?
Um, well, I don't know. Is there like a formula for it? I'm not sure.
There is, but just tell me kind of in your own words what it means for it to
Well,
be.
it's like every other number that
Okay.
starts with a one, and then it's every other number after that.
So if we divide this number by 2, if it's a if it's 1, what does that mean? Or if it has a decimal, what does that mean?
That it's even.
Yes. So the Excel is this thing called modular arithmetic, and you can see that the ones that are even have a 0 next to them.
Okay.
So what we're trying to do is create like a rule here. So like it says the odd number. So all the odd number lockers were locked and all the even ones were unlocked. So if there's a 0 here, so if this changes to 0,
Uh-huh.
then what happens? Then the other number it becomes locked. So we know it goes to 0.
Okay.
If it doesn't, it stays the way it was, or we can just say 1 for now.
Yeah.
So I just created that rule. Don't worry about that. Is this correct? Is number 1 locked? So all the odd numbers
Yes.
were locked. Actually, this means it's not locked. So I got this. If it's true, if it's divisible by 2, okay. So I just got these in reverse.
Okay.
So that means on day 2 that locker 2 is unlocked, locker 4 is unlocked. Like, do you see how
Yeah.
that's okay? Now what happens on day 3?
It changes to every third locker. So if the locker was locked, they unlock it. But if it was unlocked, they lock it.
Yeah, so this is where it gets a little bit more dicey. You have to like know what's going on with the previous like state of the locker,
Uh-huh.
because there's going to be we don't care we actually don't even care how it was on day 1 now. We just care about day 2.
Mm-hmm.
So we do the same thing. If this number is divisible by 3, oops. Okay. If it's true, this is by 3. That means it equals 0, comma 1, comma 0. Okay. Okay. So what I'm showing you here is like the third locker is divisible by 3. Then the 6th locker is divisible by 3. Then the 9th locker is divisible by 3. Right. It's not what happens though. So if it is divisible by 3, like what should happen here? That locker should go from whatever it was to the other one.
Okay.
So if there's so what we do here, and this is where it gets a little bit, it's programmatic. If the thing that you just did is true, okay, then what do we do? If this is the third locker, well, we want to change the state of the previous one. Like if it was a 1, we want it to go to 0.
Mm-hmm.
Otherwise, do nothing. So if it's true, we have to then check to see if this was a 1 over here.
Okay.
Okay, so maybe this is too complicated, and I should probably do it differently. I don't know. I feel like this is too complicated. We should do it more manually.
I'm probably.
Okay, let me start. Let me do this differently then. We got a new sheet, and let's just start with, and we'll increase the size here. Okay, so day one, they're all locked.
Mm-hmm.
Okay. Day two, if it's divisible by 2, which we only care about this one, these four, these here, we change it.
Yeah.
So that went 0, 0, 0, 0, 0. Okay. And the other ones just stay the way they are. So we don't even need to change anything at this point. Okay. Day 3, which ones are divisible by 3? Well, this one is. So it was 1, so now it's 0.
Okay. Mm-hmm.
This one was 0, locker 6, and so it goes to 1. And then this one was a 1, so it goes to 0.
Oh, okay.
Okay, now day 4, we care about this one now, 4. This one was 0.
So it's
Okay, so we have to change it to a 1. We're going to summarize this here shortly. This one was an 8. Okay, and it's now open. It's now open. Okay, so how about locker 1 though? What is it? Is it locked or not?
um I think it stays locked.
It stays locked. Like, so if we had to update it, like I would update these over here. Okay, day 3 it's still locked. Day 4 it's still locked.
Okay.
So let me do it differently, because I don't know if that was super clear. Let's go to day 5. Okay, day 5. This is the one that's divisible by 5. So now it's locked. I'm sorry, it's unlocked. It's a 0. One means locked. Is that okay?
Yeah.
So 10 was a 0. Now it's a 1.
Mm-hmm.
Okay, so let's fill in some of these other ones. So the only ones that change are the ones that are here. So these other ones stay the same. So let's if basically it's you grab the last number that was there.
Yeah.
So it's a 1. That's a 0, 0, 1. This is a 1. This is a 1. This is a 1, and this is a 0. So I'm not seeing any pattern yet, but let's see if we get one. So let's go to day 6. Day 6 is this one here. It changes to a 1. No, I have this wrong. I'm sorry. I've got it in the wrong place. It goes to a 0.
Oh, okay.
I went to the wrong one. Okay. All the rest of them stay the same.
Yeah.
And now day 7, the only one that's affected is the one on day 7. This one right down here. So it was a 1. Now it's a 0.
Here.
And all these other ones stay the same. So I'm just going to copy them over. Copy these over. So now day 8. Okay, its status is the same. So I go down here to 8. It was a 1. Now it's a 0.
Okay.
Okay, and then this is a 0. This is a 1. And then day 9. So the only one that's going to change is this one down here. This one goes to a 1. All the other ones stay the same. because none of those are divisible by 9. And that's a 1. Okay. And then day 10, the only one that's going to change this last one, it's going to go to a 0. And these other ones are going to stay the same.
Yeah.
So what you're going to start seeing is that the only ones that, like, there's eventually going to be where there's no more change. So now you're looking for a pattern in this, and you actually need to go out a few more to do this. You probably need to go out to 20 to be able to see it. Actually 30, maybe 40 ish to see this. But the pattern is it's a 1 followed by 2 zeros, then another 1. Now there's 4 zeros, and then
Oh,
eventually, and then there's a 1, and then so that what I'm trying to get to see, there's a 2, and then there's a 4, so it's going to go up to 8. So there's going to be 8 zeros, and then another 1.
okay.
So now you're looking at which locker is the 1. Well, it's the first one.
Yeah.
Which locker is this one down here? It's the fourth one. Which locker is this one down here?
The 8.
The ninth one.
Okay.
So if you put in, so if we think this pattern continues 0, there's 8 of these. So 0, 1, 2, 3, 4, 5, 6, 7, 8, I think. And then we put a 1 here.
Yeah.
This is where you sort of we have to go through and do this. That's locker 18. So it was
Okay.
locker 1, 4,
4.
9, 18. So you might see some pattern to this.
Yeah.
So you can do this by hand. We can also do this programmatically, which is what I was trying to do. I think that is worth doing in the time we have here. So let me do it this way, 2, 3. All right, so equals modulus this number, comma, this number. Let's hold the A. Let's hold the A, and let's hold the B. Okay. If equals 0, comma 1, comma 0. Sorry, I'm not giving you much explanation here, but it'll make more sense here when I copy this down. Why is it not copying down? Okay, so what this chart shows you so the first column indicates that it was closed.
Yeah.
Okay, this column, 1 means it's locked. I'm sorry, locked. They usually use open and close. The second column here indicates, okay, this number is not divisible by that, so nothing is going to change. Okay, now when we get to like, if we get to the day 2 though, because this number is divisible by 2, okay, it's gonna change positions. Like it was open and now, or it was locked and now it's unlocked. Okay, so what we're looking at is like, what happens in the numbers? Like 6, it was locked, then because it's divisible by 2, it's unlocked, and then it's locked again.
Okay.
So there's this like current status. So let me see if I can explain this. Its current status is based on the sum of these numbers. It's really the modulus of the sum of these numbers. Okay, this is probably not super clear, but the numbers will be clear. After 3 times, is locker number 1 open? or is it locked? It was locked, doesn't open, and then so that means I'm sorry, it's locked, stays locked, stays locked. But let's look at number 2 here. Let me just drag this down. It was locked. Now that was true, so it becomes unlocked. Is that right? Yes. How about for number 3? It was locked, no change, but then it became locked again.
Okay.
So we can let me see if this works here. Yeah. So we can copy this all the way down. All right. So this works great, except we need more stuff. So we need to so we need to add in a 4th day. So when I add in a 4th day and I copy this formula over and then I copy it down, you're going to see everything change over here. And that's all I guess I wanted you to pay attention to at the moment is like, do you see that it's changing? If it is, okay. And then we'll go out. So on the 5th day, let's just check a few of these. On the 5th day, boy, I hate when those cells get. Okay, so on the 5th day, let me highlight some stuff here. This is green. We'll make that one green. Okay, so on the 5th day, is locker number 1, is it currently locked? Well, it was locked. No change, no change, no change, no change. Well, then it's going to be locked.
Okay.
Let's look at number 4. Okay. It was locked. It is divisible by 2, so it became unlocked. It's not divisible by 3, so no change. It is divisible by 4, so it became locked again, 5, and so on. So let's add in a few more of these. Let's go 6. All right, so the pattern here is you just keep dragging this, and then when I copy all this down, we'll see a change here. So we got this 1 0 0 1, bunch of zeros, but you can only see the pattern up to the one that we've done. Like the 8s and 8s have to match. So that's why this gets kind of it gets really overwhelming right away. You have to sort of see it in sequences here. All right, so let's go 9, 10, 11. Let's make those a little bigger. And I'm just copying this over and then copying it down. Oops, maybe I just copy those down. And you can see those change. So 1 0 0 1, 4 zeros. We're trying to get this one, that 3rd one here. Let me get a few more of these. See if I can do it a little faster there. Okay, so this equals, I'm sorry, we're gonna do this correctly here. Equals this plus 1, and then we're gonna just drag that over. Escape, drag that over to there. Drag that over. See if I can get. All right, so now we can get up to locker 18 kind of figured out here. It goes 1, 2, 1 followed by 2 zeros, 1 followed by 4 zeros, 1 followed by 6 zeros, then a 1 again. So I was wrong. It's 2 zeros, then a 4 zeros, then 6 zeros.
Okay.
And then it's going to be 8 zeros.
Okay. All right.
Okay, so we're going to stop here. I'm going to send you this file by email, and so you can have it if you want it, and you can keep playing with it if you want. But I think the pattern will pretty much be what we just said.
Yeah.
So I'll also send you a PDF of the notes and a link to the video that's on. It's an unlisted YouTube, and I'll try and do that here in the next 10 or 15 minutes. It just takes a little bit of time to upload, but
yeah.
Send that out shortly.
Okay, thank you.
Okay, bye now.